Hey, good morning. Another day of algebra. Say, I got some emails and I understand how some kids were confused on Friday about the quiz. So let's just take a look. If we looked at Friday on September, I don't know what it was, Friday, you will see here that the direction said print off the quiz and the Pizzazz practice sheet. Complete the quiz before 3 o'clock today and go to Google Forms on the next heading down to turn in your work. So some kids didn't bother reading this part up here and they were going by their Google Calendar. Kind of my mistake too, because I bundled all these guys into one. And when I hit, when is it due? I hit due Monday, which that was the pizzazz is what I was intending for. And I was hoping that you would turn that quiz in. So it was kind of my mistake too on the due date because of it being bundled together. But number one, read these things, and in the future, quizzes and tests are due the day that they are given, and they're due by 3 o'clock that day. So make that a pretty high priority. I'll try to fix that so the next time we don't have that problem. I'm not sure how I'll structure that, but we'll see if we can figure that one out. When you went down here to submit your work, you can see that 7 kids. Well, this is because I reopened it. But anyhow, the Google form right there was right there. So we'll figure out how to do it for our next test. That is not so confusing that the due date is accurate. All right. Today you will see up here Wednesday that even though it's not old yet because I haven't made it available to you, this is my second time recording because I'm very frustrated with my technology because it stopped like 3/4 of the way through my last video. Anyhow, here's your lesson guides for today, your practice sheet that you're going to do. You print those off and then you can submit your practice sheet right there. So we should be getting kind of pretty good at turning assignments in by now. All right, let's go to today's. I'm going to try this again. I just spent half an hour to have nothing to prove for it. Fisher's getting a little frustrating with this technology stuff. So here's the warm up. I had 3 kids that came back from online yesterday, and they grabbed the study guide and they went right to work. So they totally understood what this warm up is and that it should be done by the time I'm in class. Attendance is being taken. So do those, pause the video, and when you're done, let's see if your answers are the same. All right, welcome back. Here's my answers. Hopefully they'll show up. Yep. On this problem here, you had to do this part here first, the 5 plus 3, and then times it by a -4. So if you messed up, maybe that's where you made your mistake. All right. So those are the answers they should have been. Up here, we're going to do a whole lot of this, collecting like terms today. All right, let's try this again. Solving equations. Now we're going to get the variables on both sides, and we're going to have some pretty weird answers towards the end of today. So I'm glad you're watching the video. This happens all the time in real life where cable companies, phone companies, they always have different deals that you see on TV where they say something like, we'll give you a free phone. Buy a phone plan with us. We'll give you the brand new iPhone. But then they charge more per month. Other companies say, well, you buy your own phone, but we'll charge less per minute. And so they keep changing things to keep the customer confused about what's the better deal because they know most people won't do the math. So we're going to learn how to do the math so you can be a better shopper. Okay, that's the word problem that we'll do later on today. All right, so if you notice on A, we have K's on both sides of the equation here. So what we want to do is we have to start moving some K's now, not just the numbers, the units. So I'm going to move these 4 K's to the left side. Again, get in this habit of showing some work. A lot of kids just keep a lot of numbers hanging up here. It helps keep your track of your work. I got 3K equals 15. I'm going to divide both sides by 3. I got K equals 5. Now look at over here. This is why Fisher kept saying copy the problem down, because now we have K's on both sides. So things are getting a little bit more complicated here. All right. So over here, I know that's a nice 35. Here I got 20 plus 15, and I got 35 equals 35. and it checks. Show your work over here, even on the checking part. Okay, it's good practice and you get faster at it. Now I got x's on both sides. I like to focus on my variable first, and I look and study my problem before I jump in. And I try to see which side has more of my x's. On the left side has more than the right side, so I want to do the least amount of work possible. So I'm going to do a minus 3 x's from both sides. That's a terrible looking 3. Over here I got 2 x's. I'll bring down my minus 2. Over here they cancel out, that I have just a 4. Now these look like problems that we just did yesterday. Let's add 2 to both sides. I got 2x equals 6. Last step, that says times. The opposite of times is to, whoops, I don't want to divide by 6. I want to divide by 2. Divide both sides by 2. I got x equals 3. Let's go over and check. 5 times 3, there's where my x was, minus 2 equals 3 times 3 plus 4. Well, that's going to be 9 plus 4. This is going to be a 15 minus 2. I get a 13 on the left, and I get a 13 on the right. So it checks. My answer is, and that's a terrible looking equal sign, but x equals 3. All right, give it a try. Do these two. Pause your video and come back when you're done, and then you can sit back and watch me do it and see if we come up with the same answer. All right, welcome back. Let's see what we got. This is going to be kind of strange because I have more b's on the left side than the right side. So I'm going to do this one kind of in a weird way. I'm going to subtract 3 b's from both sides. And now I have a b. 4 b's take away 3 b's, leaves me with 1 b plus 2. But on this side, I have nothing. I'm not going to panic, because here I'm going to subtract 2 from both sides. And now I got b equals negative 2. They didn't say check, so we won't. All right, so again, I study my y's. I got more over here on this side than the right side than the left side. So I'm going to subtract 3/10 of a y. Notice that I put my minus sign there so that I know I'm subtracting them. Some kids just leave it hanging there as a 3/10 y, and they say, well, I know I'm subtracting it in my head. Put the sign there. All right, so what do we got here? We got 4/10 y's minus 0.3, bring him down, and on this side I still have a 0.5. Now I work to get my y's over here by itself, so now I'm going to get rid of the numbers here, my units. I'm going to add 3/10 to both sides. Math happened. 0.4 y's. Over here I got 8/10. Last step, I'm going to divide by 4/10. And I'm going to go for my final answer, put my y first. 8/10 divided by 4/10 just leaves me with a 2. Again, we could plug that in up there to the original problem and do all of our math, and both sides should be equal to each other. All right, won't worry about that problem. Yeah, don't worry about that because that's the same ones that we just did. All right, now we're getting a little bit more involved. We got parentheses that we have to use the distributive property, and then we're going to have to isolate our y by itself. So you can see they're getting more and more involved using all the skills we've learned so far. Let's get rid of the parentheses first. We're going to use the distributive property. Now let's study my y's. I got more on the right side, so I want to subtract 2 y's from this side. 12 equals 3 y's, take away 2 y's is just y. So my answer is y equals 12. Oh, look, we're back to checking. 2 times 12 plus 6 equals 3 times 12. I know that's 36 on the right side. 12 plus 6 is 18. And I get 36 equals 36. So I know that's the right answer. Next problem, we got parentheses here we have to get rid of. So let's get rid of them. 3 times 1 is 3. 3 times a negative 2 is a minus 6k's. On this side, I got 2k minus 5, keeping my work nice and neat. All right, I'm studying my k's. I want to bring these 6k's over to the left because I would add 6k's. This is called planning. Just take a moment and say, I like to keep my k's or whatever the variable is positive, so that I will often forget the negative sign when I'm going down my paper if I have it negative. So I like to try to keep them positive, and then I make less mistakes. So over here, my k's canceled out. Now I need to get that 5 to the other side. I have 8k equals 8. This is going to be nice. Divide both sides by 8. I got k equals 1. Let's go over and check it. 2 times 1 minus 5, is that the same as 3? 1 minus 2 times 1. On my parentheses here, 1 times negative 2 is negative 2. 1 minus 2 is a minus 1. Over here I got 2 minus 5, which is a minus 3, and a minus 3. Checks. Okay. Go ahead and, oops, we got a C one here. Interesting. All right, let's do this one. I want to do some collecting like terms on this one because I see B's with B's. So now I'm going to have 3 and a minus 5B's and a plus 2B's. I got more negatives, so I know it's going to be a minus 3B's. I collected all my like terms on that side. I'm going to do my distributive property on this side, so I'm going to bring that 2 down. And I have a minus 2. Negative 2 times 1 is negative 2. And then a negative 2 times a negative 1 would be a positive 2B's. I got some like terms I can collect here. Negative 2 and a negative 2 is a minus 4. Over here, I'm just going to bring these guys down, keep track of all my work. Now I'm going to study my B's. If I brought these 3 over, then I'd have 5 B's. If I took these guys over this way, I'd have a minus 5 B's. So I like to keep them positive. So I'm going to let's add 3 B's to both sides. I have my minus 4, then I'm just going to bring down 3 B's and 2 B's is 5 B's. Let's get rid of that 4. Not really looking. So I got 7 equals 5B. Opposite of times, which that says 5 times B, is divide. So let's divide both sides by 5. Now I'm going to go for my final answer. B, because these guys cancel out, equals 7 over 5. Now that's an improper fraction, so 5 goes into 7 one time. There's 2 left over, so 1 2/5 is my answer there. We could make that into a decimal. So I know it's going to be a 1 point something. 2 divided by 5 is 0.4. So we didn't have to check on that one. At least it doesn't say to. All right, you give it a try. I'm going to do it down here so I can do less work for my other classes. All right, try it, pause the video, and start it when you're all done. Sit back and let's see if we got the same answers. I want to do 1/2 times B. Now, 2 ways you can think of this one. 6 times 1 is 6 divided by 2 is 3, or I know 1/2 of 6 is 3. So 2 ways to get that same answer mentally. Over here, I'm just going to bring everything down. I'm going to work on that side. Now, I got more B's over here because I know 3/2 is the same as 1 1/2, and over here I only have a 1/2. So I'm going to subtract a 1/2 of B from both sides. Work happened. 3/2 minus 1/2 is 2/2, and I know 2/2 is the same as 1 whole. So I'm just going to put 1B. Don't have the B by itself, but almost do. I want to add 1 to both sides, and now I'm going to go for my final answer. B equals 4. Here we got some like terms, so let's do that step. I'm going to bring down my 3x. 15 take away 9 is 6, a positive 6. I'm going to get rid of my parentheses. Now, I've done all that work, collecting like terms, got rid of parentheses. Looking at my x's, I got more over here than here, so I'm going to subtract 2 x's from both sides. Nice, I got an x plus 6 on this side, and on the other side I have a 4. Let's get rid of that 6. I got x equals negative 2. Didn't ask me to check, so I'm having an internal celebration, but I always could. I could plug a negative 2 into that whole mess up there, do all the math by order of operation, and I should get the same answer on both sides of the equal sign. Also notice again, my work, step by step, nice and neat, that somebody could follow it all the way down. You can see we're getting away. There's no way that you can do this math mentally. You can't solve for x. You'd be there all day guessing. So this is where showing your work and systematic pays off. Now we're really going to get some weird answers here. Watch what happens here. Let's do this together here and put our x's together. I have a positive x and a minus 6x, which would give me a minus 5x's. I'm just going to bring my plus 4 down. On this side, I have like terms here and here. So I'm just going to bring down my minus 5x, and then I want to say 6 minus 2 is a plus 4. Now, as I'm studying my x's, look what happens here. I have the same amount on both sides. So if I added 5x's to both sides, look what happens. My x's go away on both sides. And I bring everything straight down. I have 4 equals 4. Now that's a true statement. 4 does equal 4. So what we do is we say this one has infinite many solutions. And what that means is I can put any number in there for x. I could put 102 in. Wherever I see an x up there, do all the math and put 102 in, 102 and 102, and I would do all my work and I'd come up with the same answer. I could put 2 in there. I could put anything in. Some teachers say your answer, instead of infinitely many solutions, they would say all real numbers. So it kind of depends on the teacher. All right, both mean the same thing. All real numbers, infinite solutions. All right, let's do this one, see what happens over here. I want to put my x's with my x's. Minus 8 and a plus 9 just gives me a positive x. I want to bring down my 6. I got a minus 17 plus x over here. Studying my x's. If I subtracted an x from both sides, my x's go away again, don't they? So now I got 6 equals negative 17. Well, 6 doesn't equal negative 17. So if this is not true, after my x's go away, if it's not true, then we write there are no solutions. There is no number that we can put into those equations that would equal each other. No solutions. What we write. All right, you give it a shot down here. Let's see if I got 2 of them. Nope, I don't. All right, pause the video, work your problems out, see what you get. I really stress that you do this and not just copy down what I'm doing. Okay, give it a shot. If you make a mistake, that's okay. We're at the learning part. All right, welcome back. Let's try this and see how you did. I got 3y plus 7 on this side. On the other side, I got 10 plus 3 y's. Focusing on my y's, it looks like my y's are going to cancel out. So I got 7 equals 10. That is not true. So this is a no solution. Let's combine like terms on this side. I got c's and c's. So really I have a total of 3 c's plus 7. On this side, I got a minus 14 and a 21. That looks like that's going to be a plus 7 as well. I'm going to bring down my 3 c's. I'm looking at my C's. Looks like they're going to cancel out. If I subtract 3 C's from both sides, they cancel out on both sides. So I got a 7 equals 7. So this one would be infinitely many solutions. Or all real numbers. Oops, abbreviating. All right. So kind of weird answers. Our variable just totally went away, but we still have some answers. Okay. Here we go. Let's talk about the phone company. Here's 2 long distance rates of 2 phone companies in the table. How long is a call that costs the same amount? So anytime they're asking us to compare to get the same amount, no matter which one's used, we want to put an equal sign in the middle. So over here, let's do company A. Over here, let's do company B. Now notice, very important, all of these are in the same denomination. They're all cents, not ones and dollars. So we can just use it as it is. We don't have to say 36 cents is 0.36. If you're going to, then you have to say 3 cents is the same as 0.03 and 6 cents is the same as 0.06. But because they're all in cents, I'm just going to leave them that way. So our first company says, I want 36 cents plus 3 cents per minute. And they said down here, use M per minute. So if I talk for 2 minutes, I'd take 3 times 2, which would be 6 cents plus the 36 cents one-time fee. The other company says, well, we're not going to charge you up front. We're just going to charge you flat 6 cents a minute. So there's our equation. We want them to know when they're going to be equal. So I got more M's on this side. So I'm going to subtract 3 M's from both sides. And now I got 36 equals 3 M's. And let's scoot this up a little bit. Let's divide by 3. So now I got M equals 3 goes into 36 12 times. So now let's write our answer. It says how many minutes will be the same? They'll be the same in 12 minutes. And then they said one more part. Well, what will that cost be? Well, let's put 12 into one of the problems. One side or the other, doesn't matter. I always like to pick the easiest one. So I'm going to take the 6M and I want to do it over here and just say 6 times 12. They're both going to be the same. If I put 12 over here, I'd take 12 times 3 plus 36, and I still would get the same answer. I know 12 times 6 is 72. So down here, the cost, because they said what will the cost be when they're the same, will be 72 cents. I have units here. I have units here. Being very clear, we're not talking about 12 hours, 12 days. We're not talking about $72. We're talking 72 cents. All right? I hate these kind of problems, but they're good for algebra to practice interpreting words. But if we have 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7, how old is Greg? I know, you're thinking in your head, why don't you just go ask Greg how old he is? Anyhow, it's good practice. I want to show, let's use G for Greg. I want to show 4 times Greg's age. So I'm going to put 4G. Then it says decreased by 3. Decrease means minus. Is equal to 3 times Greg's age increased by 7. So there's my equation. Now let's study the G's. I have more on the left than on the right. So to make my work the least amount of work, I'm going to subtract 3 G's from both sides. Okay. Let's get the G by itself. So I got G equals 10. I should have probably used age because that's what we're really finding, Greg's age. So let's answer the question, how old is Greg? Greg's 10 years old. All right. So that was quite a day today. You're getting very good at equations and all the work doing tons of work to get down to the final answer. Keeping track of things really helps step by step. All right, your practice sheet looks a little different than ours. We have very similar problems, but I found a Google form that already had the answers and the problems in. So print off that practice sheet, do those problems. You have a couple word problems on the back, and put your answers in. All right, have a good day.